What's up? What's up? You should be good. You should be live. Let's see. Where's Discord? Alright, we're in. Let's get everything set up. Okay, we don't need Discord. Make sure we're good. Multi-chat's not working. Why is it not working? YouTube is up. Spam a couple messages. It's not working. Still not working. What's going on? Oh, there we go. Okay. We are in. Okay, we're good there. Let's see here. Good here. All right. Stop messing with this. We're good. We're up. We're ready to go. I don't know what this music is, but we're running it. Whatever it is, what it is. All right. Let's get the notepad opened up. Let's figure out what we're doing. Where's the old notepad? Can I not just open this with the new notepad? Open with... Bruh. There we go. All right. Don't need this anymore. We gotta fix the. We gotta do a new design. I'll write this. New design for server. That's kind of the most important thing. Look at this. So I'm gonna plug this in. See a big switch, a big button, and a little light. When I hit the big button, look what happens. room light turns on, LED goes green. Room light turns off, room light turns on. Check that out. You can play with that all day. How cool is that? So I got this ESP32. This is just a power bank, but just an ESP32 connected to an LED, connected to my big red button. I don't have the red button anymore, so I'm using the white one. Then that communicates over Wi-Fi to, no, I'm not gonna mess with that, but look at this. Let me see if I have the Brio. Alright, so shove this in the corner. So this communicates to, in the corner of my room. Can I even pull this out? So that made it a little bit harder than I thought, but in the corner of my room right there, I've got a servo on the light switch, so when you press the big red button, it flicks the light. And it's not working right now. Well, it's working. I turned off the servo. Oh, what happened? Something broke. What happened? So when you press the button, it sends over Wi-Fi to the light switch, flicks it, comes back, and lets you know that you've switched the light, which is what that LED is, right? So if I hit it, oh, it's unplugged again. I gotta find a way to mount this permanently. But when you hit it, again, it's unplugged. Come on. Let me just lock in this pin. Oh, I need something smaller. Let's try now. Alright, so the LED is right there. Flick the room light, it goes green right away. So if for some reason I want to activate the light system and not be in the room and want to know if my lights are on or off, I'm now tracking that on all my devices. And every time they're used, they're updated with the room like status, if lights on, lights off. So that little LED there is going to let the whole thing know. How do I turn that? Yeah. So that's this, and then in the room over there we got another board running on Wi-Fi with a little system that looks kind of like this. Alright, so there's the arm that sticks like that on the light switch, and then it flicks down and it flicks up. The problem with this is this design kind of sucks for a really weak servo. It's not that good. And then light switches are super stiff, so because this is pretty thin plastic, like I can, you could see me bending it around. When that light hits the switch and is hit with resistance, the whole thing does this. It just like twists out like that. So all the power from the servo that's supposed to be pushing the button is getting lost by these arms being super weak. Like I don't want to snap them because I need them for some footage, but see that? It's like any pressure on that switch is causing the whole thing to just turn and contort. So I need to redesign it because I'm using these 5-volt servos. I have another one that's a little bit stronger with metal gears, and then just for an example, that's what I was using, and this is what I want to use. I want this thing to be so strong that it either breaks the switch or breaks the plastic. I don't want the servo to be the reason the lights don't get turned on or off. Which is kind of troll, but that's kind of the whole point of this project, is just to have fun. So that's the servos. Then we have our current design for the light switching. Right? Goes up, goes down. And then servo mounts on the arms. And then I have a design already for this. This is my button holder, so I can actually, I can't really point the camera down, but I can just show you how it works. So that's my button, right? On the bottom, it's got this. Put it through the box. Put that nut on the switch, and then without breaking anything, gotta get that LED in there. Boom. And then just lock it up. Okay. Gonna have to put this on for the 10th time to a ground pin. Okay. And then there's a couple more things missing, but you kind of shove it all in this box. I should have done the LED first, to be honest. I messed up with that one. Yeah, I'm gonna have to redo that. Let me see if I can get a better angle of this. I'm messing this up. Box with the big button inside. And I just shove this LED. I'm gonna take this off completely. There we go. Now the LED goes through the box. Now big button goes in. That goes on that. Hopefully. What's going on? Okay, we're in. Then this goes in here. The button and the LED switch have to lock in. There we go. Oh no, the main LED's coming out. Okay. Now I need a ground for this. Alright. I'm gonna disconnect it. Just need a way to shove this in where it doesn't come out. Kind of like that. And then I can just that should work. Boom. Look at that. And that is completely wireless. So I'll get a zip tie, or Just use elastic bands for now. I don't actually know if I can do this with an elastic band. It's worth a shot. What a mess. Alright. This might just explode in my face. These elastic bands are super old. Please don't. Okay. That goes over there. Boom. Look at that. So now this, not so pretty setup. This is now my wireless room light control. So if I'm working, I'm done, I want to chill, the lights turn off. That's it. It works. It's not very good, but it works. I have a prototype. Now we gotta shrink everything down to make it actually nice and work. I actually have a... Where is it? Look at that. A way nicer red button, like arcade style. Has a nice sound to it. I like the big button more, but I think... how is it connected? It's fully... This is through internet. Then... I don't know if you could see it where my finger is right here. There's an Alexa. She didn't turn on. There's one of those Amazon units. And this to the Arduino is straight through Wi-Fi. Oh, my LED fell off. It's straight through Wi-Fi. Then the Alexa and my phone and my Streamlabs, everything else is through Wi-Fi. Through a server that I made. So I can from anywhere in the world turn on my lights on and off. I can have you guys do it for me. It's full. It's fully internet controlled. But this design I made is really bad. This one especially, and then the one for this servo is even worse because look, it's this, and then the servo moves this arm up and down, right, like that. Problem with it is these servos, look how small the servo is comparing to the arm. It's so weak it can barely move the light switch. Like actually, I built this whole thing, I went to film it, I set up everything, I'm filming it, and it just doesn't work because this thing was so weak it couldn't flip the light switch. So I tried this one, which is the same size, but it's metal gears and a little bit more... It's the same thing, but I put more power through it, and it didn't really work. So I just overclocked the crap out of these little cheap ones because I have so many, and I put 9 volts through it, and now it works. But it's melting this bracket, this little cheap bracket. Every time it switches the light, the whole thing flexes like this. So I have to like screw it into the wall, which is not a good solution. You know, if people want to do it themselves, I'm not gonna have people screwing drilling holes into their wall just to get it to work. So I'm gonna have to redesign that, and I'm probably gonna do that now on stream. Move this a bit. But it does work. This through Wi-Fi. Boom. Only a tiny delay. And the delay is mostly because the servo is hitting the light switch and then just struggling to finish that last 10%. Like, it's maybe half a second delay. Like, watch. Started moving, then it switched. It's like half a second. So I can clean it up and make it real responsive. So So there's that. I want to redesign this. I want to make like some nice button that looks cool and it's not, you know, open back and electronics everywhere. And then I need to figure out a solution for the light switching bracket. I'm thinking of maybe just redesigning it with this massive servo, or redesigning it for a small servo but making it a little bit better. Maybe like a longer arm. Longer arm, more leverage, more movement. I don't know. I haven't figured that part out yet. All I know is it needs to build up a bit of speed when it goes to hit the switch, and we do need a little bit more power than this. This is a micro servo 9 grams. MS18, I don't know what that means. This one is MG90, and it's all metal inside. This is like the one they use for RC cars. This one, and this is just like the cheap ones you get in the electronic kits. So they gotta redo that. But it does work. I'm happy it works. It was a headache to get working. Actually, Ben, if you're here, tell me what you think. Let me just get the paint opened. Alright, so this is kind of how it works. I think to simplify it in the video, I'm gonna make it more a little bit more complicated for myself, but it's gonna be better overall for the video. So I have my board, right? My Arduino, and that's connected to a servo, and then that's connected to like an arm like this, right? And then let's say this is my light switch here. And this goes up or down, right? Make it a little bigger. Really? I can only do 200%. I need a better drawing app. This is garbage. Alright. That's my Arduino. And it's connected to the servo, and then the servo is connected to the arm, which moves up and down, right? Then it communicates to big red button. Which is connected to a ESP32. And this connection right now here is Wi-Fi. So that's kind of the first setup, and then I also have this exports out into an LED that can either be red or green, depending on the room status or whatever. I messed it up. It like fell out of its slot, but let me see if I can get it back. I definitely need to design that part better. I'm not doing this every time. I could see it wants to go through the hole, it's just not lined up. There we go, come on. Yeah, all right. So, you see that green light there? Watch. So, board talks to light switch turns off the room, returns back the room status, which is off, which is what that red light is. And then hit it again, and then we go to green. Room status is on. How cool is that? So right now this works over Wi-Fi, this ESP to Arduino. Then, let me see if I can fit this all on the same screen. Then we have boom, 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 to PC, right? I think dog has to go out. Let me let the dog out. So I'm gonna put the dog cam on so I can see that she's not running away. Alright. Arduino talks to PC, which runs a server on it. And then that server talks to a service called... This is a bit complicated, but I'll simplify it in the video. ngrok. All ngrok does is take what's running locally on your computer and export it to a tunnel, it's called, to the internet. So I don't have to like register a server and actually make a whole thing and run my program on it. I could just tunnel through ngrok, send it to the internet, and then connect to that. It's just an easier way to develop your products without having to like do the whole process of setting up a server. What the hell's going on with the dog cam? Let me fix this. Alright. So that's all ngrok does. If I want to send something to the internet, I use the ngrok app on my computer, send it to the ngrok whatever services, and then that will send it out like this into the world. I'm just gonna draw whatever looks like a world. Very nice. Alright. Can you see everything? Kind of. There we go. So, Arduino activates servo. It's communicated by Wi-Fi no matter what. Then you have two different options. One is to talk to it directly through Wi-Fi, or one is to talk to it through the PC server, which lets it talk to anything on the internet. So if I wanted someone in the chat, in the YouTube chat, to activate my lights, I can actually go right now, set up the ngrok service, give them a link, and every time they refresh that link on their website browser, it would flick my lights on or off. Now, with this, you can set up anything to do with the internet. So, I have it set up like this. ngrok goes out to... I don't remember what the Amazon logo is, but... Great. Something like this, no? With a smile. So then Amazon will send it to their services. Boom, boom, boom. And then it goes to Alexa. And now anybody logged in with my account to their Alexa has my app. My development.
I'm not quite sure how to help you with that.
Oh, she's getting activated. Let me turn it on. So if I was to say the command, she would actually try it. It wouldn't work. She would just say like failure, cannot reach service, something like that. So then for my Alexa to activate my light switch, it has to go like this. It's me, I talk to Alexa. Alexa goes through the Amazon connection to Ngrok. Ngrok goes to PC server, and then PC over Wi-Fi connects to Arduino. This seems complicated, but it's really not that bad. I'd say like took me maybe like 2-3 hours of like sitting down and actually doing it. It's just annoying because you got to just set up all the services and go one by one, right? So you got to set up the PC server. Okay, that takes a couple hours to do it nicely. Then you got to go and do the ngrok. That takes literally 30 seconds. It's just one command. Then I have to go and register an Amazon AWS account and then do the whole Alexa app setup. Like that was probably the most annoying process. But now it works. The only thing is if I want to use this, I have to make sure that everything's running on my computer. It's not like running out there in the world. So if I actually was to tell Alexa to turn on my lights, it wouldn't work. But the issues I'm having are two things. This system sucks. Terrible. And all the physical stuff suck. All the 3D printed stuff suck. So that and this. What I want to do, what I'm thinking is, how do I make this into something that people who are watching would want to build? Right? Like, how do I make this something that the viewers would actually download and use in their own projects? I need a way that it works with the weak servo, right? Because I can make myself a fun one that works with the big servo, but how do I make it that it works with the weak servo? And they can use whatever board they want. So if they want to, I don't have any here, but if they want an Arduino, an ESP, whatever. And then you can either connect it hardwired to power, or you can connect it with a power bank like I'm doing. So right now I got a power bank in the corner of the room, and I got one right here. That's all power bank connected. I gotta find a way to design that. I don't know if anyone has suggestions on how to do that. Like, how could we design something that's cheap and easy to make, fits the cheapest electronics and works consistently, and can work with different boards? How do we do all three of those? So it needs to be, works with cheapo servo. What was the three criteria? Worth doesn't damage the lighting or the switch, maybe switch wall, I would say. Power bank or wall power. And then the last thing was what? Can work with any board. So that's the criteria. We're gonna have to find out how to make that work. The biggest issues I've had, and honestly, I should have taken it off the wall for the stream so I could show you guys. The biggest issues I've had was to make it work without hitting the screws. So here, look, I need a window. Do I have a window? So look at this. That's the light switch, right? And the way it currently works is there's the servo here, and then the arm that goes out and kind of sits like this. And this goes up or down and flicks the switch on or off. But the problem with this is this length right here this arm length here makes it easier or harder for the servo. But the problem with that is the range of the servo is somewhat limited. So I don't know if I can make it longer than this. I would make it just a little bit longer, but then I have to change the curvature of the switch itself. Maybe we keep the arm length the same and we just stiffen up everything here on the big bracket, because it's way too flimsy. Maybe that's what I do. And then, oh yeah, then one of the other problems I was having is these screw holes. When you install your bracket on top, the screw holes actually hit the arm. I don't know if this is because I installed it improperly. I don't know, but I had that issue. It just it would, like, the arm would go up and down, but it would smack those screws, and when it smacked the screw, it wouldn't let the switch go all the way through. And the servo was already so weak that when it smacked the screw, it would just completely dead stop on the screw. So I got two options. I think one of them is I'm gonna ramp, just make a late baby ramp right before the screw holes, so that the arm does, like, slide and tap over it. Or I could just make the whole thing thicker. I could do that. I could make the whole thing thicker. Let's try this. I have the file. In one of my YouTube video folders. Let's see. Yes, I have them as STLs. So what we're gonna do is we're gonna go. Wait, is STL good for shaper? Yeah, I think STL is good. All right, grab these. I'm gonna send them to the iPad. What do we need here? Also, it would be nice to make it work. Oh, this is a good idea, actually. Just flat out extend the whole thing. That's not a bad idea. Ooh. There's a couple of good ideas there. Alright, we'll come back to this. So we need to get those files on the iPad, and then I'm gonna redesign them. Make some changes. Let me see, full cam plus iPad. Can I put screen here? Let me see, 6724 is the code. Why is it not working? Oh, here we go. 6724. It's not working. Oh, it is working. Alright, nice. Let's make a new project. Let's go back to screen share for a sec. Or let's just go main cam. I'm gonna just get the files from Discord without leaking. Just give Discord a minute here. I don't know why it's being so slow. Come on. Why is Discord so slow? What the hell? Shama with the question. What if you build the whole thing into switch plate and then oh yeah, that's actually a super good idea. Build the whole thing into a plate and then just replace the plate entirely. That would work. I just don't... Do all plates have the same mounting holes? I feel like they don't. I feel like it depends on what you have under it, no? But I guess that anyways, the mounting points anyways, we need them to be the same. I don't know why Discord is not loading. Oh, it's updating. Great. Wait, Shama, if you can, type in the YouTube comments because I didn't see your message until I opened Discord. Because I have my other OBS thing open. Alright. I love that Discord is updating and it's just sitting there, it's not moving. And prioritize download. I don't understand. There we go. Still just perma-loading. We could do that. We could design the whole thing into the panel. That's not a bad idea. I'm trying to think about it from a 3D printing perspective. What would be best? I think that would make the most sense. Because I could just make it into a box. And you just mount that box and you just have like a place to plug it in or whatever. And maybe I'll just put a button on it. I think that would be the best option. And I can even put like an override. I can put 2 buttons on the box. I can put one to flick the lights on and off. And I can put one to override anything that's incoming. And just block it. Because let's say, I don't know, for some reason you want to lock the status of the light. Do you want to do that? Like, would you ever want to lock? I guess that defeats the purpose, right? The whole purpose is I don't want to get up from my chair to go to that light switch, hit it, and come back. That's the whole premise of the video, right? I want to be able to just continue doing what I'm doing and not have to get up. That's the whole joke of the video, is just like, I think the first line in the video I say is like, getting up and walking out of your chair is a conspiracy theory from Big Pharma. Some stupid thing like that. Okay, here, we're in Discord. Alright, download the files, please. Open in Shaper into current project. Import. Hey, we're in. Alright, and then go into the other file. Switch arm. Give me a sec here, I'm almost done. Import. Boom, okay. Wow, we're on. Alright. Can you guys see this good? Ben, Shama? How's this iPad view? Looks good? So, can you guys see my mouse when I use it? No, you can't. Alright, I'll just use my computer mouse over the iPad. So, this part here is the arm, right? And the arm goes kind of like this, but more like this, right? And that's what flicks the switch on and off. This is actually a really cool way to show it. So the problem was that these two big arms here twist and bend when you put any power through that servo motor. And if that servo motor ever gets stuck on anything, the whole thing stops working. One of the things it gets stuck on is where my mouse is right now. There's a hole, right? And there's another one right here. Those are the holes for the light switch panel that goes over it. When this thing goes like that, oh, I can't show it. Okay. You see the space between the arm and the bed? Between these two? The screw is a little bit higher than that. So when that arm turns around and it's already struggling to hit that switch and there's a tiny little bit of resistance stopping it, it's just complete stops. So we need to figure out a way to kind of clear up that section. I like Shama's idea of remaking the whole panel. I think that would be really nice. I just have to measure up that panel and then make some new designs and we just completely remake it. I think we're gonna go with that. Let me bring in the dog. I think we could do that. And then might as well redesign everything else to kind of match around it. And it wouldn't be too hard because I already have all the locations from this. And all the heights and all the measurements. All I need to do is clone it over to another design. Which I can show you how that's done. It's pretty simple. First thing I'm going to do is I'm going to hide this. So we don't need it anymore. And then we'll make a new folder and we'll hold everything inside of it. Okay. So the first thing we need to do is to lock down all of our key points here. We have 2 screw holes. We have a switch hole. We have our servo mount. That's it. And all the spacing and distances between them all. So all I'm going to do is I'm just going to redraw them. Doesn't have to be perfect, like that's fine. Even, you know, that little space there, I'll be able to fix that. So, let me see. I'm actually gonna make it a little bit bigger. So that's our hole for the switch, right? And that's on like the most top layer here. Then we go to the circles, we repeat the process. 5mm hole about. Just get close to it. Again, it doesn't have to be perfect, but do it like that. It's not as fancy as Fusion 360, but this kind of works. So now if I was to hide this, boom. Now we have our mounting points and our screw hole. Sorry, screw hole and switch hole. And then all I gotta do is pop that back on and it matches up perfectly, close enough. Now I'm gonna repeat the process for the servo mount. So the most important part of the servo mount is these circles here. I'll make them match just in case. Oh, they don't match. Alright, whatever, that works. So we got our little servo mounting points there too. And then I'm gonna make it a little easier on myself, and I'm gonna just record this. How can I do this without messing it up? There we go. I just want to know my clearance on how much space I have for the mounting part. Just get a little bit more, come on. So I know that I have kind of this much space here. Right? That's kind of my contact points for the servo. So now if I go back here, see, now I have everything important that I need to get to make this. Nothing else matters. As long as I follow the rules of these measuring points, the rest doesn't matter. Kind of. I do like Shama's idea though. But how can I combine it with this? Like, I really like the idea of somehow mounting everything over the light switch like a box, and having maybe like a screen would be really cool, like a little OLED display. Ooh, an OLED display saying light on, light off, an LED. I have plenty of options of what I can do. You don't really need an LED to tell you if the room lights are on or off, I guess, right? You don't need a light to tell you if the light's on. You would know. I guess I'm getting a little bit too complicated with it. A little display, a little OLED display, and where is it? We don't even need an OLED display. What am I talking about? We just need a button to be able to flick the light on and off without messing with the servo. Because once the servo is on, it locks its position. You can't really push it out of it without hurting it. So I need a button that lets me override whatever's on there. What else could there be? I don't even need to use an Arduino on there. I can just use another ESP. I just realized. I could put in 9 volt, 5 into the board, 5 into the servo. I just realized how complicated I made this. Okay, here's what we're gonna do. We have all our mounting points. Let's figure out what we want to install on this, and then I'll go get those parts from the parts bins, and then we'll go from there. Another thing you can do is cut a channel in the part that swings so it doesn't make contact with the screws. That's what I'm thinking. Or I would just make a contact area for the arm to make sure it never goes below a certain level, because it kind of sags, and when it hits that screw, it has to like jump over it. So if I just made it where it always stayed at a consistent level, it would solve a lot of my problems. This is a good idea. Let's do this. Let me switch here to... Can I minimize this? I don't know why it's not like a window I can just minimize. There we go. Okay. Let's get the notepad. So let's talk about the wall mount system. Well, you need a board, to, like an MCU to control it. I think ESP32 would be the best. Something small. If not 32, I could just do 8266, the one I've been doing. It's called 8266 node MCU. I wrote MCU twice. We need, I would say, an override button. Then I would have a 9-volt input, DC connector, I think it's called. I already have that. What else do we need? Shama, help me out here. I'm trying to figure out the part list so I can design around that part list. I'm gonna have like a hole with that DC input and just plug in the 9-volt that I have. It's just a long 9-volt to the power. I'm gonna have an override button, which needs a hole in the print. Then we have like the regular stuff, which is the servo. And that's kind of it. Externally, we only need to worry about two things, which is the DC in and the override button. And I can build around that a little bit. I have some tricks for that. I think that's it. I can't think of anything else. It would be cool to have an OLED, but I can add that as an extra. I have some ideas of what I can display on that OLED. I'll keep them for the video. I think that's it though. We don't need power bank. We don't need an Arduino, whatever model that is, R4. We don't need a big board. We can do the smallest board possible. Yeah, that's it. Okay. So with that, I'm gonna shove it down here and then bring up the iPad again. We're slightly blocking it. There we go. With that, we just have to build the rest. All right, let's get it. I know I've got one here. I just don't know which drawer it's in. There we go. It's gonna be a little bit hard to see, but you see this lets you have a DC input, and then you just got two cable outputs on the other end. And I could just make, I could just either solder to it or make some pins and have that in my 3D print. And then when you plug it into the wall outlet, it's going to send power directly to my board and my servo and any electronics that I have in there. So that's perfect for that. That way I can make this like an actual unit. You can plug into it and build it yourself. And have it all nice and clean. I do think we're going to have two restrictions here. Not everyone is going to have the same board, right? So we need a way to change. We need a way to make something that can have different boards in it without impacting how the servo and the switch interact. I'll give you an example. Let's say everything on the iPad right now, everything here cannot be touched. So we have to build something over that. Let's say this. We'd have to build something like that, but that kind of looks like crap. I could. Thing is, I don't want to make it. I don't want to make it extend to the side, because there might be another switch or something important next to it. I need to make it go down or up, right? So let's say we made it like this, right? We don't want our Arduino and electronics to be held like here, because that would block if there was another switch. So we need to make it either go down or go on top. I feel like on top would be better. What do you guys think? How do we do this? Servo sits like this. That's actually a little bit trickier than I thought, of figuring out how to make that work. I think I have to do it like this. You know what? Let's first build it out. Let's build it out. So this I would make. Where's my calendar? I'm gonna match the dimensions I already have, and then we'll adjust it how we want. I'm gonna extend this a little bit, just like that. So like we can mount this any way we want. I think one thing I didn't check. One thing I should measure is the dimensions of the switch panel. Let me do that. It's around 66 by 115. So this would be 66. What the hell? Oh, wait. I just messed up. $66 by 115. So that's the dimensions of the current panel. And I guess the servo hangs off it just a little bit. Now, like Shama said, we could do our own panel, and that would make things a lot nicer. Because then I can just go like this, and I know that I have from here to here. Actually, you know what? This is a good idea, Shama. Here's what I'm gonna do. I'm gonna use this white space here to mount all the electronics. I'll make the board slide in. I'll make the board slide in with any electronics in there. I'll have the servo on one side with the flicking mechanism. And then I'll just have a cap on top to close it all. I think that's the way I'm gonna do this. And then the button will be on the outside. Okay, let's do it. So, I'll explain a little bit more. I'll explain what I'm trying to do. Let's say from here to here, let's say 20 millimeters. That's actually not a lot of space. It's not a lot of space, but we'll make it work. For 20 millimeters, we know that we're not going to be touching the mechanism. I'm going to give myself as much as I can. Let's do 22. And then just to confirm it doesn't contact, we'll do it like this. We'll grab this piece. That works. Go top, look down. Yep, it never touches. Alright. So, we know that this is kind of our clearance area here. I'll visualize it in a sec here. This we can bring down. I'll just double whatever this is. This is 1.5. I'll do like 3.2. All right. So that's our switch panel. Oh, wait, I'm getting pinged on Discord. What's going on? Wait, Shava, come to the YouTube chat or something. I don't see your messages. I don't want to ignore you, but I don't see them until I open up Discord. I never have YouTube chat open. Alright. I think we'll do like that. So that's our switch panel, right? We'll redesign the holes after for the screws. I'm gonna lower the screws into the print. Now we just need a way to cleanly get up the servo stuff. I can either make it one big box or I can do something fancy. I don't really have many options. I kind of just have to make it the way I make it and that's it. So let's say, how much out is this? Also the servo takes a bit of width. No, it doesn't. Let's say we do 16 millimeters out. And then we match that with this. And then we repeat the same process down here. I think this would work. And then I would just make the box extend. Oh, okay, it's erasing. I'd make the box extend kind of this width and a low profile. I think this would be my best option here. Okay. Then, here's where it gets tricky. Actually, it doesn't have to be tricky at all. We could just focus on pure strength. Since we're not going inside that light switch, we can kind of just do something like this. I think I might have to thin this out a bit more, which is fine because it's going to be stronger on the sides. I think I'm going to have to do like let's say -1 for now. And what's this? think this works. And then I can just connect these by probably just bringing them out. Let me see if this one goes to option here. Let's say if I did something like this. I grabbed a square. I made it. Let's just make it thick for now. It doesn't matter too much. Go more than that. Go like 15. Because for this, our biggest worry is that they twist. So I could just strengthen it. I can strengthen it, and I can just ignore all the rules that the nice design already does. So let's say we do like this. Go up here. Grab this and this, and just straight bring it down. Right? What is this little nudge here? What the hell is that? Like, maybe I didn't draw a line straight or something? That's weird. Whatever. So let's say I did it like this, right? Like I said, it doesn't matter about being strong here. Or sorry, it doesn't matter about being nice because it's all contained within the box. Then, so we have servo mounted, we have this mounted, then we need to work on our screw holes. So let me just grab this. Let me see if I can hide it. Can I hide it? Yes. What I was thinking for the screw holes is I could just measure the screws. Oh, I can't get under there. Let's say they're about 7 millimeters. Right? So what I can do here is I'll thicken this back up to 3. Then I'm going to go here and overlap 2 7 millimeter holes. That's 9. Do 7. And then on those, you know what, I'm going to be safer. I'm going to do 7.5, so I don't have to reprint over 0.5 millimeter. Then I can grab that, and bring it down 1 millimeter. See, now they're going to sit lower. They're not really going to interfere, and if I want to be safe, I don't think I have to worry about it being strong or not. I can do 1.5. Now they're pretty much fully gonna seat into the whole design. And let's say my arm is sitting too high and it slips off of the switch. I can just redo these and make them sit lower. These little nubs here. Right? I could literally just lower them if I wanted to, up and down here. That solves that problem. Now let's put the sketch back. Let's open our box back up. So this is our new switch panel, which would completely work with our design. The only fear I have is it won't be straight, but whatever, it's fine. I really can't. I can't overdo this part here. I just realized I would be hitting the wall. So it has to be a really perfect fit. Alright. Then, what I'm going to do is, I'm going to grab all these. And I'm going to hide them all. And then I need to hide the sketches. Where's the sketches? These two. Alright. Now we have the most important parts to work with here, which is the switch panel itself and our minimum height. I'm gonna grab an extra ESP board. It looks like my ESP8266 is not much thicker than a normal ESP32. So just to make our lives a lot easier, we're going to use the one with pin out and a USB input instead. Yeah. And it has a Wi-Fi card on it. So no need for fancy shit, just plug it in and it works. Then I'm gonna have to build a case for it, and the case has to be at least either this height, so at least 30 mil, or ooh, that doesn't fit. I'm gonna need like 40 something, maybe even 50 to be safe. And then what's the width here? Okay, we'll be good on that. Okay, so we need at least I'd rather it be a little bit less than a little bit more. Let's see. I think 40 will work. So our box will be 82 by 115 by 40. That's not bad. That's not bad. I'll lock that in. So we're gonna do a little construction plane. We'll bring it up, let's say 100. Then on this, I'm gonna use a tool called projecting, which is gonna project this from here onto this. Boom. And now we have our lower box onto a second sketch. And then that could be raised up to what do we need, 40? So this is kind of what it would look like. That's the rough sketch of what we're gonna have. I think that would be better than having all the exposed electronics the way it currently looks. Let me take a picture and you guys tell me what you think. See, so this is what it currently looks like, which is not so nice. What's up, Julius? Check this out. The room lights, they work, and it's on a big red button. Not so bad, right? Completely wireless, no, just a battery and some stuff. This is like our prototype. I'm gonna make it a little bit nicer, but it works. I now can activate my room lights from wherever I am. And it also works with Alexa, which is back here, but she's muted because she keeps talking. And it works with my Stream Deck. Check that out. Look, I'm not touching the red button. Stream Deck works. I can send one of you guys a link and you can do it online. It's completely hands-free now. But we're gonna try to find a way to make it a little bit nicer so I can make a file for it and post it on my website for free. And then anybody who watches the video and wants it for themselves can go and get it themselves. And actually make it. I'm gonna use like the cheapest, most accessible electronics. So a normal, oh wait, you don't see the screen. Normal servo, like that you get in those kits. These are like, I think you get like a pack of 30 of them for like 20 bucks or something. So you can get them super cheap. I'm gonna use some 3D printed parts. This is the prototype, or not prototype, but this is someone else's design that I tried that's not very good. Moves like that, it hits the switch, but it has some issues, like it literally full twerks out like this when you put some power through it, and because it's bending, the force isn't going into the switch, it's going into the bend. Because the switches have a lot of resistance. So we're gonna completely remake it into something nice. Yes. So this is currently the design I have. This is the box that will go on top, and then under it will be that. And you still don't see the screen. That. So this is kind of the cover, which again this is the functional design. This is not the nice looking one. That's on top, and then you unbolt it, and boom, you got all that mess under. What do you think? That's the current design. Like later on I can come in and fancy this up and do all the rounded edges and all that stuff, but I want to get like a functional working thing. I'm going to use a smaller board to make this work. I'm not going to use an Arduino because they're a bit too big. And I'm going to use some DC connectors to make the box. You don't have to open it to connect it. You just plug it in like something you would get at a store. Pretty much. You know what would be nice? It would be nice that once you build this whole thing, you never have to like take it apart and wire things together. Like you can make it, give it to your friend, and just install it like that. Do these have Bluetooth ESP32s? Anyone in the chat know? Are these Bluetooth or just Wi-Fi? I have an idea. Where's my... This. It's called the ESP8266, I think. Node MCU. Node MCU. Does it have Bluetooth? No, the standard does not built in Bluetooth functionality. Wi-Fi capabilities. Okay, Bluetooth, you must use an external module. Damn. ESP32 does. Ooh, maybe I need one of those then. Wait, hold. Let me see if I have any. I have a couple of ESP32S. ESP32 cam. Let me see if that has it. ESP32S. Yes, the Node MCU ESP32S on Wi-Fi and Bluetooth. How hard would it be to set Wi-Fi name and password through Bluetooth to these? Maybe I could just make it. Oh yeah, it does have Wi-Fi and Bluetooth. It says it right here. Okay, hear me out. Hear me out. We might have to redesign some of this, because let's say I made the kit, and I said to one of you, hey, if you want to make this for your home or for a friend, here's how to do it, right? Your friend might not be a technology person and might not want to open up their code editor to set a name and password. So what if there was like a really basic web app that you connect your phone to Bluetooth to this, and then you could just set your internet and password on this. And then that way, you could give it to your friend and they can set it up themselves. I don't know if this makes any sense, but look. Right now, the way this works is, we're here. This is our switch situation here, so, right, so this is what we're redesigning here. This needs a password and a name to connect to the Wi-Fi. I guess the switch does too. Fuck. This needs a password and a name too. But once you set those, they can communicate to each other over your Wi-Fi. So if there was a way to do that through your phone without being a person that knows how to use a code editor, that would be ideal. Because then I can make this kit, right? I can make the button part, I can make the switch part, and I can make it super intuitive where the person who installs it doesn't have to like tinker with it. I don't know if this makes any sense or if I'm just talking in my own head right now, but let's say, hear me out. Let's say I did something like this. Okay, I'm gonna take this box here, take this and this box, and I'm gonna hide them. I'm gonna hide this. Okay, hear me out. Hide this. So we have our like design here for the screws, right? Oh wait, I don't know if we can do this because of the servo arm. Oh crap. I just realized the issue. Because I can't make direct external holes to reach the screw holes because the servo goes in the way. So I can't have anything in the way of the servo. What I was gonna do is this. I was gonna have, let's say, like a tube like this, and that goes all the way through the box. And then when you have the box closed, someone can just stick a screwdriver, go all the way to the hole, screw in their box, and then have to open it up with all the electronics inside. That's not gonna work. You have to open it up to install it. But once it's installed, you don't have to care anymore. Ooh, I didn't think about this. One thing I want to check is, how common are the light switch holes that I have? Like, is this do you guys have this in your homes? In your apartments? Whatever you live in, do you have this exact type? Like this with the spacing, or is this like an old one? Like mine looks like this. Mine looks like something from the 90s. With like a brown panel. I know people have this stuff in their new homes. I know EU has this. And then some people have this. With a really big spacing. I guess I just have to assume that they have this. Yeah, we have no choice. We'll have to assume. Okay. Alright. So we have the servo mount, we have the switch hole. Quickly before I forget, would be nice if we can just... Can we not hide this sketch? Oh man. What is this crazy ass schizo music? Okay. Before I forget, I'm gonna grab these edges here, and I'm going to do the same thing we had before. Something like this. The most important actually is just this. Like that for the switch to flick. That looks good. You can add a little matching one here just to make it nice. Alright. Okay, here's the dilemma. How do we make it so that you don't have to open it up to mount it? I don't want people drilling holes in their wall. I don't want people using glue. Anyone have any suggestions? How do we split up the mounting process? Oh, Screeper, I just see your messages. What the hell? Why don't I see your messages in this one? Okay, wait, I'm using a bad chat, guys, sorry. I just got a bunch of messages from people. Screeper said, what are we working on? We're working on the light switch, and probably got that. Do you have a servo on the switch? I do, yes. My bad, Screeper. I have like 2 stream chats and one of them wasn't displaying any new messages. I wonder how long it's been. Whatever. So how do we mount this without, let's say we have the box contained. We have the servo set up with the flicking arm. We've got everything sorted out. Like one thing I'm gonna need 1000%, I just realized, is I'm gonna need like an access window here. What I'll do is I'll match it. I'll project this and this down to here. What the hell is that? Where's the project tool? Tool, project. Brother, what? This and this to here. And then I'll use those to make myself a little access window like that. You could use mounting putty, Gorilla Glue. Yeah, but I don't want to make it a permanent solution. Like, I'd love that you can build it. You let's say you're better with electronics. You can build it, you can connect the servo, you can upload the code to the board, you can do all the annoying little things, print it, whatever. And then just give it to your friend and be like, hey, if you plug this into power and you connect it to your internet through Bluetooth, it's gonna work, and you can give it to anyone as a little gag gift. That way it's like, it's not just within the 3 people who want to build it, it's outside of that. Or if someone doesn't want to know or use code, they don't have to, they could just connect the electronics and follow along. I want to be able to mount this on the wall without opening it, but here's the problem. Maybe if I explain it, it's going to make it easier for me to understand the solution. So we have this, right? Now, this goes like that. right? You see the screw holes, one above, one below. You see how it's fully covering the screw hole right now? That's our issue. We can't have anything block. Now, I have one solution that I don't love, because I think it'll make printing it very complicated. I could technically, this is a real ugly solution. I could do something like this. And then something like this. Oh man. Okay, you'll get the idea. But let's say I had like a really thin plate that keeps the arm within a certain range, and I could do another one on the bottom next to the screw hole, and then the arm would go past the screw hole, but when you're mounting it, it won't be in your way. Let me see. Oh, but it is in the way. That's not gonna work. The display magnet stuff? What is that? It's like a... isn't it the art that's magnetic on the wall? That's not a bad idea. Does it have to be a full enclosed thing, or could you just have two stick, one on top of the switch, one... Yeah, well... you could have it like this, which is how it's currently set up. I don't know if you saw it earlier. I don't like this design because everything's exposed and it looks ugly, and I think a person that doesn't understand electronics or doesn't want exposed electronics won't like it. Also, this is super flimsy. Like, look at this. So like, anytime the servo has a little bit of pressure against it, the whole thing twists. So no, it doesn't have to be full enclosed, but I think that would be the best look. I think that's how I'd want to do it. I'd want to make it like a unit that you can make it and you can give it to somebody, but now I'm overcomplicating it because I'm trying to understand the best way to mount it. And I think that's the problem. I think I just need to make it mount and then deal with the rest later. So that's what we're going to do. What we're going to do is we're going to... Okay, here's what we're going to do. Put everything back. Sketches back. Put this back. Put the box back. Where's the box? There it is. Okay. What's our clearance here? 2.9. That's not a lot. We're gonna move it into. We're gonna empty it out. Well, it was a 40 mil box. Let's do 38. All right. So now we have a box, right? This box will go like this, and I'll make a way to mount it and close the box. I have a couple ideas on how we can do that and make it look nice. What do you guys think? Something like that. And then on this, we'll have some holes on the side, one for the DC mount, one for the override switch. Maybe I could put the switch on top, like here. That'd be pretty cool. Where's my switch? I brought a button with me. Did I not bring it? I had like a nice little push button. Oh wait, you guys don't see the screen again. See this little yellow button? Just push it and boom. Turn on the light. Turn off the light. You guys gotta call me out sooner when you can't see the screen. I end up talking to myself for 30 minutes. Okay, here's what I did when you weren't looking. Right, that's the box. It's emptied, hollowed out in the middle. I think this is the way to do it. And then I could just have everything mounted, everything wired up inside here nicely. And then I would just have the box enclose it. That's it. And I can build like, here's where I can make it nice. Actually, you know what? We'll do this now. And I'm just gonna make this the actual one. We'll just do it now. There's no point in delaying it. I'll just use this footage for my video if I have to. So, here's what we need. I need a 2mm lip from here to here. Now I know that that's my bounds of where I have the cover coming down, right? What happened to it? Okay, we'll do it again. 2mm, and then we'll do another. Let's see, how thick is this? We'll do a little bit more just to make it sturdy. Let's say 4. So now really we have that. And we have this, right? Now this is our enclosure bounds. What I mean by that is this will fit. The box can close with that. Anything more out here, it will not close. That's our tightest technical fit. We can adjust it later. And I definitely will. I want to make it like fit nicely. I'll probably make the box go over the edge. That'd probably be the nicest look we can do. And then on this part that we just made, so let's say, what, we bring this up, let me figure it out here. Let's say we bring it up 20. Actually, 20 is kind of really high. Where's our ESP? Yeah, actually that would work. That would work. So I'll bring it up 20. Let's say I don't need it. I don't need much. I just need one hole for the DC mount. So let's say 1mm there. Let's say another 20. Let's say this is another 40. So what is that? 10, 20, 40, that's 70. Let's say 70, 80. So grab this, do a line like this. Let's do 80 to be safe. It won't let me. I just realized something. The way mine's set up, this isn't gonna work too well. Whatever, I'll adjust. I'll adjust my setup. Okay. So now that we have this, where's our 80 line? We're gonna close it out like this. What the hell? What's going on here? Okay. And then I see some real design magic. Tap the edge. Oh, what the hell? Oh, it's not working. Why is that not working? I should be able to just click this edge and delete it. Something's wrong. Yeah, something's wrong. Whatever. I'm gonna just do it myself then. What the hell's going on? This is what's annoying about the iPad stuff. Sometimes it's just buggy. Fusion 360 would never. But Fusion 360 takes a certain type of psychopath to want to use. Still doesn't work. Like, I should be able to lock that in and then tap this edge and it will split it on that line. I guess I'll just have to do it from here. If it's gonna be buggy like that, I'm not gonna waste time on that. So I'll do my line, 80. Or you know what? It really doesn't have to be perfect. I can do like I could do it like this if I want. And just pop that out. Pop that out. Yeah, there we go. You said 20, right? Boom. So that works perfect. I just realized something. If I make this box any bigger, it's gonna hit the edge of a wall. I guess most people don't have it set up. Yeah, it's fine. Ignore. We're gonna do what looks best. And then my setup is weird. Like, look at the picture I showed you earlier. Can you guys see this? Yeah. So, mine's like a homemade built garage or whatever. I was worried that, like, here... I was worried that like here it would hit if I make my box any bigger, because this border is touching here, right? But look at this wood, it's like literal homemade wood. I'm just gonna chop it off if it gets in the way. Like it's a homemade border and it's all cracked and done. Might as well just rip it off. But then I can have that space, you know, to fit a box here. I think that's what I want to do. And then I can have my design be beautiful. Yep, I think that's what we're doing. That's what we're doing. We're locking it on. Okay. Go back to this. So, box will go down, and then on that box right here, we have to make 2 holes. 2. First one I want to do, I want to go like this. Make a line. 2 mil. Make another line. 4 mil. Like this. Now this is a 4x19. What's our switch here? 17. That's gonna fit. I'm gonna raise. This will make sense in a sec here. Let me cook 2 mil, and then what happened to my sketch? What is this buggy ass software? Like, look what happens. It just disappears. Man, Shaper, get your shit together. I have a feeling it's this time. Yeah. Alright. Bro, what is this? Alright, now it should work. Yes, thank you. So now I can put this up, let's say 20. And on this, hopefully this works, I should be able to go 2 millimeters out, 4 down, and just delete that. Yes, okay, here we go. Now, this is another bound for the box. This is where I'm gonna mount my switch. My button. My override. When I push it, the lights will flick on or off. Then, on this side, I don't need this whole monstrosity. Is that the word? I don't need that whole wall, so I'll clean it up a bit. But I need maybe, what, 25? And then what's the ESP board width here? 40, so let's do 38. Let's do 39.5. Keep it clean. Now, this really better work. There we go, finally. Alright. Remember, these are just walls to line up the box and the thing that's inside the box. Okay. I think I'm gonna extend these out to the edge, and then I'm gonna make my box go to the edge. I'll explain this in a moment. Yeah, that's gonna look way better. And then I would just shorten that to 4. Shorten that to 4. Shorten that to 4. And then I can go in here, sketch, trim, delete all these annoying ass buggy lines. Oh, what the hell? Okay, I guess I can't delete the lines. Alright. So what will happen is, for the things that are mounted directly onto the, let's call it the base plate, like the DC charging port, that will be mounted into the base plate, and then the case will go over, but not where those things are. So if there's a switch, the case will have like a hole in it, and when you lower the case, it just will go around the switch. It won't go actually into it. I think this is the only way I can make this like a clean design. And easy to print. That's the most important. I'm trying to think about easy to print. And it's not looking pretty right now, but I'm just in my head, I'm imagining where would the printer head have to go to make this. And by doing that, I can simplify a lot of my prints and make them higher chance of coming out strong and nice than if I started doing some crazy design work and then when you print it, it looks like crap. So I think that's good. I think that's good. Now all we need to do is we need to create two things. We need to first make the holes match in the case. So, what I mean by that, I might have to do a line here through the whole project. So watch. The true middle of the project is that line right there, that midpoint. Right? When you lower the cover, which is, if I remember correctly, this? Yes. Oh, we have to modify the cover first. So we're going to extend the outside by 2 millimeters. Oh, crap. Extend it by 2 millimeters on every corner, and then we're gonna make the hole in the inside bigger by also 2 millimeters, right? That way, now, when you lower it, it's gonna fully enclose. Look at that. Now it just looks like a straight box. There's no side things. And I can either make it snap on, which I don't think is going to be a good idea for this. I think I'm just going to make two screw holes, one on top, one in the bottom, hidden somewhere. And when you lower the case on top, you can just screw in your little screws, and it's going to be locked in. What do you guys think? How does that look? Well, not the box itself, but like the idea. And then, to make it even better, to do what we're about to do now, I'm gonna click on section view, and I'm gonna click on my little line here. How do I do that? Okay, I'll just draw a new one. So you click on your line, and then you click section view. Section view. Why is it not working? That's weird. I might have to do a little cutting window. Let's see. Add construction plane and set it to line up with. Doesn't have to be perfect, just for this. Now if I click on this and I go section view, there we go. Okay. Now we can see the print sliced in half. Now we can do our little operation here. So this is the button side. What I'm going to do is, I'm going to line up this box, and I'm going to make a hole here. Look how nice and simple that is. That hole is going to match our little baby switch, which is 13.2 millimeters in diameter. So we're gonna slice that up to like, let's call it 13.31. Then, look how freaking fancy this is. Boom, pop a hole. Nice, isn't it? I'm gonna have to do a couple more modifications. The measurement I just gave was the measurement of the actual screwing part of the switch. But the switch also has like a little top mushroom part, which is 17.5. So I'm gonna do 18. And then one more step into this mess. I've never done this before. I should be able to just go like this, like this, like that, and like that. Oh my god, look at this. And then pull that in too. Amazing. Amazing, look at that. So, how can I show this? The switch is gonna fit in that hole, and when you put the box over, it's gonna fit like that. How incredible is that? And then, if you really want to get fancy with it, if you want to be one of those, and you want to, you know, like the chatters that complain all the time, here's how we can get really crazy with it. We can take the outline here, boom, boom, no, this one, yeah. Okay, we can take that outline, project it onto this print, and then take this print and push it out. And that way when the box fits on top, you're just gonna see little, we'll fix these gaps. These gaps are not right. Right, this is not right. But this is just giving you an idea of what. I'm gonna have to reset this one. Does this make sense? So, I'm gonna mount the switch to fit a certain way, and then you're gonna put the box on top and it's gonna look like a seamless fit. Well, seamless, it's a 3D printed part, you're gonna tell, but my point stands. That's gonna look so good. That's actually gonna look so good. Then, that's kind of done, right? We can, well, it's gonna be a little bit of a headache to get in there. Get in here, we could just make that a little bit bigger. Look at that. So, I can take the case off, on and off, without having to deal with the button being on the case. You know, like sometimes people put the buttons on the case. Or think about like, if your button was on your door would have to have a wire going from the door to the wall to whatever. And every time you open and close your door, you now have a wire that has to like extend and retract, right? Kind of like how in car doors it works. You have like a literal loom that goes to your car door. And when you open and close your car door, this loom has to be free enough to move. I don't want to do that. And I don't want someone like ripping off the case and ripping the button with it and now having like a messed up thing. So this way everything's mounted to the base plate, and then you just put the cover on and that's it. And you take the cover off and it doesn't rip any electronics off with it. Anyways, this is a real over-engineered way of doing it, but that's gonna look so good. Now I just need a way to... Where's my plane? I need a way to like... I think I have to move it like this. There we go. Now I just have to repeat this process here. Crap, there's a lot of garbage here. Thing is, like, I cannot delete it because it will. Dude, what the? Can I just highlight? Hide that, hide that, hide that. Just hide all these sketches. Okay. What do you guys think so far? Did you learn a thing or two? And then I'm just gonna do this. Zip tie is what? Let's say 3 millimeters. I need to move this whole thing. Say one here, one here. I'll do like a zip tie up here and a zip tie down here. Something like that. Actually this is too close to the wall. I need this to slide into a little slot. What is this? 1.8. How do I make this work? How do I make this work? If I made something that went like this, let's say, how thick are most boards? Let's say they're like 4.7, 2. I'm just gonna make this work for my board, I guess. Yeah, I think that's gonna have to work for my board. So let's say say 7 millimeters off the wall, so 10, and then we'll add 10. Let's say we'll do, oh, I really can't do much. Like the wall has to be there. Okay, so the whole thing is 6, and the middle is 2. Let's do 8. And then on the 8 we'll do 1 here and 1 here, and then close it out like this. And then the height of that 8 has to be say 7 millimeters, 7.5, that works. So like this. And then height was 27-ish. Something like that. That way we can just sandwich the board in here, and I'll just remove a little bit of material. I'll make it like 2.9. And then I'll go here. 2.9. Okay. Check the chat. Works. think then we have to repeat the process of the hole. So I've got my DC thing here, and let's measure it up. We've got a 10mm external, 7mm internal. So grab this. A 7mm internal. Let's say, what's the real number? 6.7. Let's say we take it to 7mm. It should fit. I'll do 7.1 just to be safe. And then I can take that and I can move it down. That's not gonna let me. I'll do it here, 7.1. And then I'll take this hole and I'll extend it all the way through. That's not much space there. I think screw it. I think we just make it bigger on top and let's say like that. And I do 7.1. Perfect. Now I take that hole. Open it up. Now repeat the process. Got a 10mm lip. Let's say we make it 11. I feel like I need more than 11. I'm gonna play it safe. I don't want to reprint this 10 times. I'll do like an 11.2. Then from that, make an inside circle, and then we do this and this. Bring it down. Repeat the process. 2mm, and then like before, we can just make this line, this line, this line, and this line. Boom. So now we have that. That's not so bad. Now we have our DC charging port. And that will fit on top perfectly. I think the next part we have to look into is how do we do mounting points without interrupting anything. I think we have to do one top, one bottom. I think that's our best option here. So this would go like that, boom. And then let's say we hide it for a sec. So, ooh, that's close. Oh, actually, I'm good, I'm good. That's good. So I have, let's say, I kind of have like a screw is what size usually? Let's say 6mm. I'll probably need like 12mm of space. So let's say I want to do this, and I want to copy it over to this edge. Oh, it's not going to let me do that. 12 by 12 by. How deep do I need it to be? This is good. I'll make this about 1. 10.5 is good. Okay, here we go. Do this, so it's 12 by 10.5. 12 by 10.5. Boom. And then we could just delete that. Then I can lift that up 12. And now the whole case will drop down and match those two. Then, once the case drops down, where's the sketch for that plane? And then the case was body 6. All right, so now we got to make it line up again. So drop it down, boom. That's how it fits. This is going to go 90 degrees, and then we're going to split section view again, and then we're going to hide it like that. All right. Then in here we need to make the holes for the screws, and I'm going to check which screws I want to use. I've got these like assortment of screws here. I think it's going to be the best to use like the most low profile one, kind of like this. I think those should be fine. We don't really need strength, we're just going to need as much low key as we can. Alright. So these are 3.64 millimeters, let's call it. Or yeah, let's do 4 mil on this, and then drag it out. And then on this we can make it 4, and on this we can do like a 3.85, let's say. Just tighten it up a little bit. So 4, 3.8, we just repeat that on the other side. So we do section view, section view. I have to bring that sketch plane back like this. Sketch plane and the box. Where's the box? 6. I don't understand how this works. Sure. Alright. Repeat the process. So 4 mil. Tap it through. Outside. 3.85. Boom. So now we have our two mounting points. Maybe just to clean them up, I can like divot it, and I could do something like the size of the head. Just let's say 7 mil. I can bring it in like a mil and then just chamfer the edge. Do something like that. This might be a little bit too thin. We'll have to play with it. Maybe I'll make it like something like that. 1 mil is real thin for a part that you're going to be putting like tension into. It's going to snap. But that could work. Also, I didn't think about it. Printing that is going to be a headache. That's actually really bad. I don't want to print that. Yeah, just leave it like that. Keep it simple. Keep it simple, stupid. Okay. So now we have our box. What is this? We have an issue here. Ooh. Okay, that's fixed. Not so bad. Not so bad. I'd like to clean it up a little bit. I think around all the external edges, make it look a little nicer, something you'd want to have on your wall. Maybe a little bit more modern, not just like a junction box. So we're gonna hit it with the corner. With the corner method, I like to call it. This is when you don't know how to design. But, oh my god, can I just get the corners? So you grab all the corners, all of them. Then you hit him with the apple method. Apple's like 6, but we'll do 4. Oh, but wait, I need to print that upside down. Oh, that's so annoying. Unless I just print it upright and I say I don't care. Yeah, I don't care. And then what I'll do is, I'll take this line, project it onto this, and then, boom. Problem solved. Look at that. Can I go more on this? No, I'll leave it like it was. 4 looks good, and I think I still keep the strength inside. So that's the mounting hole, that's the switch hole, that's the 2 screw holes. Anything else I'm missing? Maybe we can make a little ramp. Maybe we can make a little ramp for the arm, for the moving arm, just to confirm that it's not hitting those switches. I've never done this, but let's try it. Let's say I do a 15 millimeter circle, and then I go and I make a construction plane and I raise it up. Let's say what? Let's say 2 mil. And then I go here and I repeat. Let's say I did that. I should be able to loft it. There's this tool called lofting. It's like you take kind of two shapes that are the same shape but different sizes, and you can like glue them together through space. No, it's not gonna work. Okay, my idea might not work then. Unless I make it off the side. Yeah, I'll do that. So it was like a 5 millimeter and a 15 millimeter hole, let's say. So I click on this to match the level, and I can go here. Let's do a bigger one since we have the space. Let's do 20. So if I take this circle, right, and I make it 20 millimeters, and take another one inside, stay with me now, and I need the, let's say 7. Let's say 7. I don't know. Okay, whatever. We'll just put 7 for now. Then I should be able to just... Oh, wait. I messed up already. You add a construction plane on this. You move it up the amount you want. So we said 2. Then you put the secondary shape you want. So I'm going to put here 7. Then you go to your tools, loft, and you have this beautiful ramp. And then you can go in here and you can do your inner shape. Boom. And now can I select it or what? Yeah, there we go. Now I have a ramp that I can take here. Oh, that's a mismatch. What size is this? 7.5. So move this out to 7.5. Yeah. And then bring that thing back over here. Let's just say. And now this gives us that ramp to move the arm up and down if it ever decides to hit there. It's not necessary, but and I can just do this. Isn't this beautiful? Oh, yeah. Isn't designing cool? Now I messed up with this. I messed up bad with that because I didn't put it back. It's fine. Hell yeah. Look at that. I'm just gonna have to clean it up and make it nice, but that's not bad. We got our hole here to put in our DC charging port. We got our little, whatever you want to call it, we're gonna call them stacks, these things. These are just going to let the ESP slide in and kind of sandwich and hold it in. Then we got our screw hole. Ooh, we might have to move these out actually. We've got some conflicts here. Move this out a little bit, like this, let's say. So that's going to let our ESP32 go in. Then we have a screw hole for the screw to close the whole thing up. Then we have our buttonhole right here. Then we got our servo mounts, which we definitely should clean up. And we got our bumps. Our little bumps for the arm. I think I might even be able to... I should have left a little bit of a lip there. Oh, I could do this. So with this I can adjust it up and down. Perfect. Now what I'm going to do is I'm going to grab the whole thing. And I'm going to move it up 300. No, I need way more than that. I need like 500. Now we have our Gen 1. This is going to be called Gen 1. So we're going to grab all that, put it in a folder. And then we're going to rename it Gen 1. And every time we make changes, we know we're making changes inside of Gen 1. Alright. Now that we're here, we can kind of clean it up and make it look good. So I think what I'll do is kind of just go through all this stuff. All the sharp edges and stuff that you might not necessarily need, it helps to kind of clean them up a little bit. You don't have to do much, like this is a bit overkill, but just clean them up so that they don't conflict with anything. Right? This one is going to be sticking out, we're going to leave that one. This one's going to be sticking out. Let's say, are these all connected? Not this. So connect this to this. We can use the tool for it. So that to that, boom. That to that. Union, where's Union? Union. Boom. What did I do? I clicked the wrong button. Yes. Then connect this to the base plate, Union. Then connect this to the base plate, Union. Beautiful. We'll leave the circles for now. Is there anything else we're missing? If I tap the base plate, so when I double tap the base plate and everything goes blue, I get to see what is part of the main print or whatever and what is not. So those two circles are an individual item to the base plate. So I have to take watch of that. But now that everything's connected, I can kind of go and really make it look good. Well, when I say make it look good, I'm just gonna clean up some edges and stuff. Add some stuff like this. Boom, 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 boom. I think I'll do it like that. Those are going to be annoying, those little bottom spots here to print. This is going to leave like a mesh of plastic, but it's fine. I'll take care of that. Let's clean this one up. Adding curves to things sometimes helps make it print stronger, just because you're kind of fusing things a little bit better than just straight lines. At least for me, it makes a difference. So I always try to add a little hidden bumps like that, just to really clean things up. Is that it? I think that's it. We don't really want to touch this stuff too much because that's going to be exposed. I think that's going to work. Now, what's really, really, really important, now that we have that set up, first of all, we forgot to clone our box, which was body 6. Yes. Now we're going to take body 6, we're going to move it 500. There we go. Now we got to double check everything lines up. It does. Boom, 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 it lines up. Now what we're going to have to do is take our Gen 1 there, and we're going to take this. I'm going to rename it as Gen 1 case. Now, this case is going to have to have some little bit of tolerances added. So everything that I know that might mismatch, I'm gonna hit with this little trick. So that, this, 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 this. Alright, now I should be able to go minus 0.1. Let's see. If I get real close and I undo. Yeah. That's going to give us a little bit of space on the prints to clean it up. And if for some reason that's not enough, repeat the same process again. Just add another 0.1 until eventually it fits nicely. You don't want to do it too much at once, it's going to look like shit. So that is going to be good. Yeah, I think this is good. It's ready to print. Might even just slap it on the printers now and just build a test one. And we'll just update in the Discord if it goes well. I think it's going to look good. We can put a, you know, we can put a design in here later. I'll do that. Oh, you know, I'll do it on the 3D printing software. We'll do it together. I'll take the few viewers who are still in here. I'll take you through what it's like. So now on the iPad, what I gotta do, I got my prints, right? What I'm gonna do is, I'm gonna make sure the only things that are shown in my file are the things I want to print. So, in our case, that's going to be Gen 1 case and Gen 1 base. Rhymes, it goes simple. Then, oh, and wait, do we want to show the 2 bumps? No. No, should be fine. Yeah, it should be fine, should be fine. Going to export these. Export. STLs. Make sure set each first item level separately is on. Then I'm gonna send it to my Discord and send. Great. Now, oh, it just crashed. I really hope I didn't. Oh, it's updated. Well, let's hope it's sent to Discord and it didn't just delete itself. That would absolutely suck. Okay, we did get something in Discord. Gonna download that. I'm gonna minimize these. Can I minimize them somehow? Whatever. That's so bright. Open up the printing software and a file window. Grab that. We're gonna go to 3D print. Where's YouTube videos? Okay. Now in here, I'm going to create a folder called Gen 1 wall. And inside of that, we're going to throw in this. Unzip it. Okay. We can reuse one of these projects. Boom. Are these files a single object? No. Alright. Pull OBS back up. So now, let me make another plate. Just clean this up. Look at that. Now you have... Why is it tilted? What? Did I do that? No, okay. So now we have our relay mount with ESP32 cam holder and a DC in and a power switch. The power switch will go like that, boom boom into this. I probably should have added something to keep this nice and tidy. Whatever, I'll use like hot glue for the first run. I'll make it work. I'm not too worried about that. And then, oh look, the bumps are there. I think the only thing left. I don't know. I think the only thing left is to print these. Make sure that they're supported properly. So. Why is this like another window? What the hell? What in the hell? I have never had this as an external window in my life. Yeah, okay, that was weird. Alright, now I just need to print these. And I think I'm going to print this one like that. It's going to waste so much plastic, but I don't care. I really don't care. I got my PLA profile, I got my printer profile, I've got my strength profile. I'll make it super strong. All my speed and everything is locked in. Yep. Let's go turn on supports. They are on. Okay, let's generate plates. The PC doesn't crash from this. Why is it so slow? It's just... Yeah, well, yeah. That's gonna look like crap at first, but it's fine. So, yeah, that's good. Send it. Print that stuff right now. Flow calibration, bed calibration, yes. It's the beauty of having two printers. Just print both at the same time. It'll be super quick. This one's gonna take 4 hours. I'll be done at 8 p.m. tonight. Okay, how long is this one? This one's gonna be a pain in the ass. Oh, that's not that bad, actually. That's not that bad. How long does it say? An hour and 40 minutes. That's not bad. So every time I mess up one, I could just reprint. Hour and 40 minutes. Let's do it. Send it off to the printers. One's getting started. Two is getting started. Let's see if we can see the camera. Look at that. How fancy is that? I got both printers on their own servers. And I can just watch them from here. Don't have to turn my head. Alright. Those will do their job. I don't need the iPad anymore. I don't need Discord. Alright, let's see. Is there anything else we're missing today? I wanted to do a new design for the wall mount. I'll do a new design for the button myself. I think that's it. I think that was it. I don't know if anyone's still here from the earlier group, Shama and Squeeper and all of them. But I think that was it, boys. Look. I think I'm gonna make it like way smoother and cleaner and into small little units. I got batteries and everything that I can operate these boards from, and I'll just make it into like a really small package. I think that's what I'm gonna do. I don't like how big and bulky this is, but for the video, for the first prototype, it has that. I like how it doesn't let you spam. I put like a spam protection in there, so it'll only go when it's available. It will not queue up commands. So and it always updates. How cool is that? I don't know, I played with this for hours. Whenever I'm just bored, I just like boom. Boom. It's too fun. It's too fun. Alright, well, I guess that's it. I'm not gonna drag this on any longer than I need it to be. Been going for 2.5 hours, holy. So, yeah. I guess that's it. I'm trying to think what else I need to do. Let's see. Design the light system. We did that on stream. We need to redesign I think that's it. Stream Deck works. Alexa works. That's it. Just redesign it, make it nice, and then boom, 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 video. Yeah, I think that's it. On like the engineering side. Yeah, I'm gonna leave it at that. I don't want to spend more than a week on this, so I already did like, I'm close to a week, so I want to build this all today, print it out tomorrow, and make it happen tomorrow. Alright. Well, for the boys who are still here, thank you for watching. Shama, thank you for the suggestions. It's actually gonna look so good. Look at the printers, they're already going off. Yeah, this should be good. This should work really well. And I don't think we're gonna have that annoying twisting problem. And if we do, I'll just make these bases way thicker. I'll just extend them out all the way out here, and then I can even make some sort of like from here to this corner, and that would be something to attach the wires to. Like I can go crazy with the design on that. I might have to actually. I might actually have to. I might have to make like an arm that goes from this servo mount. Oh wait, you guys can't see it. I might have to make an arm that goes from this servo mount to this screw hole, like some sort of bridge, and then the wires coming out of the button will get zip tied onto that bridge and go this way to the ESP, because I can't have him in the way of the arm that goes up and down. Yeah. But that's gonna be actually crazy once I get that work. Once I get it to work, it's gonna be so nice. And it's gonna be all in a little package. You install it once, you lock it on, don't touch it again. Then you got the case that fits on top. And I think for the video I'll do a clear case instead of a blacked out one. So I'll do a black board, or maybe some sort of colored board, and I'll do a clear case. And then you can just see through the clear case what's happening inside if you want like a cool little electronics wall thing. But yeah, it works. So I guess if you're looking forward to that, for those who aren't subscribed, subscribe to the channel. The video will come out in a couple days. I just gotta finish building this. That's what I'll work on tonight. And then tomorrow I gotta film it all. Yeah, tomorrow I'm gonna have to do a big film day and film all of that. And then we'll be good to go. So yeah, if you enjoyed, you enjoyed. If you dislike, dislike. And I'll see you guys in the next stream next week, next Sunday. Today we're the 22nd, so the next one will be on the